right, hello. Is it working? Yeah, awesome. So, like you said, thank you for joining. I will be talking about taking over the PHP supply chain. If you don't know if you want to stay because you saw PHP, the clickbaity title would be find silly bugs and own 20% of the internet. No, I hope it's not for you. My name is Thomas. I go by Swap.js on Twitter. And I have an offensive security background. I used to do pen testing and bug bounty. And nowadays, I'm a vulnerability researcher at the Sonar R&D team. With Sonar, we build a product to make clean code, to help developers to write clean code and ship secure software. And on a research on an open source project, we uncovered last year more than 40 high or critical vulnerabilities. And we got 3.0 awards nomination, including one for this talk as the most underhyped research of the year. Which is, I guess, I'm not making clickbaity enough titles, but we didn't win, but still, we felt really, really honored to be nominated. And today, I wanted to give you some background knowledge on package managers, like what are package managers, what are supply chain attacks, because it's kind of a buzzword, and I'll try to give you some more information about this term, and also a little bit of PHP. Then I will show you how we could compromise two package managers and the impact it would have across the PHP ecosystem. And then a small talk about blue art stuff, like how to mitigate the impact of such bugs, and then the usual conclusion and question and answers. So Tidelift, which is a software company, they estimated that 92% of all commercial software are using open source components. So in every single piece of software you use, there's probably some open source stuff. So you need to find a way to include, configure, update, install this little piece of open source software in some bigger pieces. So for this task, you use a package manager. And you may already know package managers with on Debian, Ubuntu, apt to install new software, and it's not in scope for this talk. We'll only be talking about package managers for developers. So it's whichever tool you use to download new front-end libraries for shiny buttons for your interface, payment provider APIs because you need to interface with people, or Braintree or Stripe, just you name it, any piece of software you pull from somebody else. And if you have some development experience, I think you already saw one of these few logos. For JavaScript, there's NPM, Yarn. There's even one for LaTeX. There's a few ones for Java. And it's like every ecosystem, every language has their own package managers. And most of the time, there isn't only one, but a few package managers for every single ecosystem. And I couldn't make a definitive list because there are too many package managers. And so like I was saying, the goal is to aim deployment of dependencies. So a dependency is just another piece of software written by somebody else, like a third party produce some code and you want to put it in your own project. And you need to identify it by a name. So it's either some unique identifier like its name or the GitHub style way of saying author/name. And for some of them, you also have the notion of scopes for big projects, and you can reference them by scope. And you list all your dependencies in something we call manifest. Could be JSON file, XML file. Sometimes you have your own custom, let's say, scripting language for it. And in this file, you will put constraints. Could be, okay, I have no reason to include my PHP unit test framework in my production environment. So I will just exclude it from any production deployment. And same for version. Maybe I want version 4 and not version 3. And for software like Composer itself, oh yeah, it works awesome. We have here's a name. We have the library. We say it's a library, and then it requires PHP version 7 or version 8, and we have sub dependencies like this, and we have the constraints on version here. For pip, the syntax is slightly different. It's a bit easier. It's not JSON. We just list dependency like this. Version constraint. I don't want to forward it for the .0 because maybe there is some breaking change in compatibility, but we don't care. And these dependencies, they may have their own dependencies. And the dependency of the dependencies may have their own dependencies. And that's what we call transitive dependencies. It's all the tree of dependencies you need for your software to run. And different package managers, they all have their own way to store the dependencies. It could be a tree, like you just include every single dependency with the dependency itself. So for Node.js, sometimes that's why we have big Node modules folders, is because every single dependency embeds its own dependencies and so on. But for other package managers like Composer and I think pip gem, basically you try to resolve all the version constraint at once to get the states. And the final state with all your dependencies and their own versions are stored in something that is called a log file. So if you saw something called composer.log, package.json.log, it's basically the state of your package manager. And it's needed to create reproducible builds because, for instance, if you build something on your dev laptop and everything works great, and then you send it to production, but somebody put like a new buggy release of some essential package of your software, everything will break in production. So you need to ship the state so the production server can install the exact same version and the exact same everything. And another specificity of this log file is that you will store the URL of the files to download, because you need to make the association between the name, so the name of the package that we like /bar, and the URL to download the actual package from. And to make this association, you need a metadata server, which is any kind of, let's say, HTTP server hosted by somebody somewhere that will make this association for you. And to ease the deployment and the creation of new packages, this metadata servers, they need some submission interface. So most of the time you have some small web interface where you can just send you the URL, use the name of your package in it, and then everybody will be able to install your package. And this metadata server is rich only during install and updates, because like we said in the log files, you already store the URL, so you don't need to reach out to the metadata server again. It's only during the install step and update step. Now, supply chain attacks. It's kind of a buzzword because like it's the kind of terms you will see in the press, and it groups a lot of like many different scenarios with many different risks. And it's basically a way to describe any attack that is not directly against your software, but instead against anything that was used to create or make your software work and exist. So it's basically based on the fact that you inherit all the vulnerabilities of the things you're using to create and run your software. And the ENISA, the European Union Agency for Cybersecurity, they studied 24 supply chain attacks in 2021. They did a like pretty good job, better than me, to just classify everything, make taxonomies, and they identified like there were at least half of these attacks coming from non-threat actors. So it's like it's a real world thing. People, cyber criminals, threat actors use such attacks to conduct, with their offensive stuff and to gain access to companies and organizations. And they expect a fourfold increase in 2021, mostly because of ransomware actors. Because if you compromise one piece of supply chain, you may impact a lot of customers. And anything can be attacked. Could be shipping. I will show you later some example of like intercepting shipping boxes to backdoor hardware. Could be also hardware, like if you buy a phone on, I don't know, on eBay, and it's already backdoored, it's kind of a supply chain attack. Could be your OS, it could be a backdoor in Windows, could be packages, some angry developer willing to break everybody's software. It could be compilers. Your compiler could be building intentionally wrong code, introducing backdoors or vulnerabilities. And all of this is just based on the fact that a chain is only as strong as its weakest link. So it's easier for attackers to just target this weakest link of your chain, basically. And for advanced threat actors, it gives you perfect offensive capabilities because you can either be very targeted and yet say, it's not me, it could be anybody else. And on the other hand, also be very opportunistic and try to spray your payloads around and conduct mass-scale attacks and just make a lot of noise, but in the end, only target a few specific organizations. One nice example is this one. So here we have this is a picture coming from the Snowden revelations and the Greenwald book called No Place to Hide. And everybody we see, I think there are 3 or 4 people, which are from the NSA, and they are using a heater gun to remove a sticker from the Cisco box. And then they would just take the router from the box, add some hardware implant on it, and then put it back in the box and send it back to the original customer. And then you would say, okay, my package is delayed, which is not unusual, but you would get a completely different router with a backdoor allowing the NSA to get back in later, which is pretty nice. And there was another one on PHP a few months or 1 year ago already. And their Git repository, git.php.net, got compromised. And somebody introduced a backdoor that would just evaluate any incoming code, if you gave it in the right HTTP header. So basically, if it attained some like a server, if it was deployed somewhere, anybody could just break in, just sending the right request. And hopefully somebody saw it quite quickly, so they just reverted it and everything. But it's pretty crazy because like everybody's using PHP. There is also some well-known and headlines, WOSI stuff like SolarWinds, where allegedly Russian hackers, I don't want to give any opinion on that, just broke into a company called SolarWinds, which is an infrastructure IT monitoring software. It's basically a software you deploy on your network, and then this software has access to all your network and can just simplify IT administration. But if it makes your system administrator life easier, can also make your attacker's life easier. And they basically backdoored the installer of the software and waited for a few months for all the customers to deploy it. And customers would be people from state departments from the US, big private Fortune 500 companies, and they would just wait for them to deploy the new update and just come back and break in. And they would prove that they really stole a lot of data using this attack. And most recently, and same, I don't want to fall into the attribution trap, but the news that these guys were just 16 years old kids in the UK. We'll see if it's true or not, but they basically tried to require to pay people, like pay insiders, say, hello, I know you work at, I don't know, Apple or Okta. I will give you some money, like 20K, and you will help me to get the initial foothold and try to get over the network. And then they try to conduct attacks. And the big one we saw, I think last week, was on Okta, which is an identity provider. And by compromising Okta, they would be able to reset any password of any user of any customer of Okta, which are also basically big software companies. So by compromising one single central component, they would be able to just reset anybody's password on most companies, and it's pretty crazy because they would just be able to come back or VPN or try to log in some internal apps. There are also supply chain attacks which are more related to package managers. One of them is any kind of squatting, could be typo squatting or bit squatting. And the goal is to submit packages with deceptive names, because when you have to install package, you have to remember the name of the package. You could type it wrong, like silly keyboard mistakes, like you are lib with only one R, or sometimes, you never remember is a dash, is a 2 or 3, I don't know. So you just type something and it's the wrong one, but if somebody registered it, you just deploy attacker's code on your computer. And there is something I really like, which is bit flips. I always thought it was like a myth, and it's true. It really works. Because sometimes you have some bit flips in your requests, and if you register domains which are like 1 bit away from the original one, like all the 2 domains are 1 bit away from windows.com, but could also work with packages name. If somebody registers it, it's like you will also pull somebody's code on your computer. Pretty nice. And there is also expired packages, usernames, emails. Okay, let's say I created my account on NPM, and some old email I just deleted because I don't use it anymore. Somebody can just register the same email address, do a password reset on NPM, and then take over my own packages. And that's what happened a few months ago with something called AJV formats, which is a package with 5 million weekly downloads, which is a lot. And it was transitive dependency of Webpack, which is a huge JavaScript software. And basically everybody was pulling this thing, but it was lying around with let's say no security on the account, because anybody could just take it over. And when it comes to account takeover, there is always the usual stuff like weak passwords. I don't know, if I use password as password in my NPM account, everybody can basically take it over. And 2FA is not always mandatory, even if it's not perfect, but it adds a little layer of security. And there were also some examples like news headlines for UA parser.js, which is some user agent parsing library that had also millions of downloads every week. There is also spear phishing. Like if you really want somebody's account, you can just spear phish him to death, and it will always work because phishing always works. And obviously there is always money, like we saw with lapses, with insider access. You just pay somebody to give you his account, or you can also sponsor development in exchange of ads, which is basically paying developers to put malware in their own software. We saw it a lot, I think, with SwordForge back in the days. And finally, there is something much more interesting, and that's why I'm here today. It's like compromising the backend services. Like if you compromise the server doing the association between the name and the actual URL to download a package from, you can just send or redirect the package manager to any other URL. And it's the most impactful scenario, because instead of breaking in one package at a time, you would just break in all the existing packages hosted in one ecosystem at once. And some other researchers already did it. So it's Max and Realtek. They basically took over everything. Homebrew, which is the package manager for macOS. CocoaPod for Objective-C, packages, Ruby gems. So there is some initial work on the side. And we're like, okay, maybe we could try to do the same. Like, wouldn't it be really cool to compromise all the packages of one ecosystem? And how expensive would it be? Like, are these guys really, really good? And I'm sure they are. But did they have to take months to do it? Was it like really hard to do? Did they have to find some crazy 0 day somewhere? Or was it like objectively, technically easy? Did they need a lot of time? Or could they just do it like this evening on their room, just on their laptop? And did they need a lot of money, like quantum computer? Or is it, yeah, something I could do on my laptop? And we picked PHP because modern PHP is trendy. I'm a PHP guy since the very beginning, and I still fall in love every once in a while with PHP because there is new language construct, new syntactic sugar, JIT. It's pretty nice nowadays. Like, it's a real language. And it's run 78% of the internet per W3 tech, which is a lot. But WordPress alone is like 43% of the internet. So we're left with maybe something around 30% of the internet running PHP. And you need package managers. Like in real life, you need to include some open sourced software in your own project, so you need a package manager. And Kai from a team estimated that around 70% of all the PHP projects are using Composer. So let's say if we take over all the package managers of the PHP ecosystem, we could maybe break into something around 20% of the internet, which is a lot. So we'll show you how we took over Composer. Have a drink. So it was initially released in 2012, so it's pretty recent, pretty new, and it's now by far the most popular PHP package manager. So we have 55 billion installed since 2012, which is a lot. And every day, every single day, except weekends, because nobody's working on weekends, there are 78 million packages downloaded. It's a lot. And the metadata service is open source, and it's called Packagist. It's maintained by the company running private Packagist, which is the, let's say, SaaS version to host private packages for PHP. And this usage is not decreasing. Yeah, you can see there is 1.5 billion monthly downloads of packages, and the curve is not slowing down. It's like everybody's using Composer, and even if the screenshot is like 2 weeks old, but if you go look at it, I'm sure it will be at 1.8 billion monthly downloads. It's crazy. And like I said, everything's open source, so we can easily audit it and deploy it. So we just created our own VM with Composer running in it. Just took a few minutes. And there was a simple package submission process. So to add new packages to Packagist and to Composer, we just create a new project on our own GitHub repo, create a Composer.json file to declare our project, so its name, the kind of project it is, if any required dependency. We host it on GitHub, it's a version, Mercurial, you name it, just any kind of source, hosting system. And we create a Packagist account, which is free, and we submit the URL to the repo. And it just looks like this. Like there is no need for anything more. It's a simple interface. You put the URL, it will fetch it and create a package with the same name. And then everybody will be able to pull it from Packagist. And behind the hood, like internally, Packagist is using Composer for most operations because you need to pass the Composer.json file out of the library trying to pull. So behind the scene, you just clone the remote repo along with tags because every Git tag is a version. You pass manifests, and then you create it in the database, and then it's just available for everybody else. And all this step, like cloning and everything, is done by Composer. And there is some logic code to try to identify which VCS, so like Git, Mercurial, Subversion, which VCS is running on the other side. There is a fast path for URLs, because if you say GitHub, it will probably be some Git repo. But just in case it doesn't match the URL, it will try to run Git ls remote on the URL you gave to try to see if the remote end is speaking it. And then it will try svn info to try to see if the remote end is speaking Subversion. And then try AJ to try to see if the remote end is speaking Mercurial. And it will just iterate over. And as you may have seen here, it's escaped. So there is like some security things happening, and it prevents command injection vulnerabilities. but behind every patched command injection vulnerability, there is an argument injection vulnerability. I will just show you what it's like. So basically, it's not real PHP, it's some pseudocode, but here we have value control, which is something of date, and this sequence of characters here are a way to execute subcommands in bash. So basically, if you put in the shell, we'll first evaluate date and put the output of date in the next CLI call and then call everything. So if we run it and we just append it to AJ-identify, it will create this shell script with AJ-identify and date. So it will evaluate date and then run AJ-identify and then with the output of the date command. But with the write escape function, it won't be exploitable because it will put single quotes around it, preventing the evaluation of the dollar parenthesis sequence by the shell. So it will basically run AJ-identify date, which won't do anything, which is not nasty, but you can still add new arguments to the option. So basically, if I do this, if I put --help, it's escaped, so there are no single quotes around it, which is okay, but the shell will still call AJ-identify --help, which will show the help menu. So we know we can add new arguments to invocation of Git, Subversion, Mercurial, and it's something that is pretty nice. There are always the usual suspects like Vags and Joan. They always find argument injection in Git stuff, like Vags found a lot in GitLab, and Joan found argument injection in Git itself. But the problem is it's running Git as remote, which requires positional argument. And we only have one injection point. And to exploit it for Git, we would require 2 injection points or at least another value somewhere else. But we can still look at others, Subversion, Mercurial, and there are also some crazy ones never saw before, like Perforce and Fossil, so we have room for mistakes somewhere else. And indeed, when we looked into Mercurial manual, it says we can create aliases with the same name as existing commands, we can override the original definitions, and if we put an exclamation point, we can make it a shell alias. It's basically, we can override any existing command. So we can just, since the code is running AJ-identify here, we can just override identify. So the final syntax is --config equals alias.identify equals !date. And if we run it in a shell, instead of running AJ-identify, it will run to date. So basically, we can go over Composer and run it. So at the beginning, I'm just showing some IP address, just making sure everything works. But on the top right, it's Alice shell, which is, she's the attacker because, his name is red, so she's dangerous. And on the left, we have the packages interface. So we can just register a new account as the attacker. And then I will just type what you saw, the --config equals something, and I will get a connect back shell. So a netcat connection coming back to the attacker's shell. So it's just starting a listener, so we get the connection, and we can speak with the other end. We click on the left, and then we get a shell. So it works. But it's okay, we get SCE, and it's pretty nice, but I don't know, like if you're not very technical, like okay, command execution, it's fine, you get a new server. But I will also show you how to change the metadata values, so we can force a developer to run unintended code. So now the attacker is just getting a nice shell. It's not really important. I'm typing slow, sorry. So yeah, we got a real shell. And then on the left, there is me, Thomas, and I will just go to my own packages and I have like something to print nice waffle emojis on my terms. I will just, on the bottom right, install it. I just Composer require it. It gets downloaded. And then I can just run it. And I have my, okay, it's small, but there is really a waffle emoji. And then meanwhile, the attacker is just going in on the shell and changing metadata for this package. It's basically a JSON file, like the actual metadata on the server, it's a JSON file, and listing the sources, which are the location where you can download the packages from. So it's either Git or a zip file on GitHub. So you can just replace this file by something else. And then if I go back on my own shell, and I want to update my package. I just type composer update. And it's weird because there is a new version, and I never deployed a new version to the left. So something definitely happened. And if I run it again, something else happened, and it's just a browser with a video, but could have been anything else. So that's it. And obviously, we didn't do it on the real instance. It was like a test VM. But on the real instance, just to try it, we just send a listing of the current directory back to a server we owned. And that's how it looks like. So if you also get a SE on Composer, you will be able to verify if I'm lying or not, but I promise it's a real one. It's same tree, same structure, and you would just have to go to the P2 folder and just override the JSON file. And they fix it quite fast. So it's fixed so they had to fix it in Composer because packages was using Composer and the vulnerability was in Composer itself. So they just released a new version in Composer. And basically to prevent argument injection, you add 2 dashes. It's called the POSIX end of option marker, and it prevents the interpretation of any value after this 2 dashes as arguments. So basically the patch is just show new characters. That's it. It's over every existing VCS driver, but so the patch is pretty large, but I mean, it's just 2 bytes every single time. And the timeline is pretty crazy because we found it maybe late at night. We just sent the email, and the morning, they say at like 8, said, yeah, okay, we now deploy the hotfix on the public instance, like even after a few hours. And so it was fixed and safe on the public instance. And then they took some time to just make the right patches and release a new version of Composer and make the official announcement. So everything was really, really smooth. And yeah, thank you, Niels and Jordi, which are the main maintainers of Composer, for the help. You can sponsor them on GitHub, on the Composer page, because yeah, it's honestly one of the best timeline I could ever have. And now we'll take over P, which is the PHP extension and application repository. And it's basically the package managers that was used before Composer. And it was created in 1999. It's moderately active nowadays, but you know, there was always some historical software that requires some historical software to run. Also written in PHP. Last commit was like 1 year ago, and they tried to modernize it and create a peer too, but it never really took off. So people are still using peer. It's less. It has to put back like it was 1999. So basically, you know, internet was different thing than nowadays. But they still have like 290. Millions downloads since the very beginning, and they still get like 100,000 monthly downloads for the big ones. There are a few big names you maybe already saw somewhere else, like Archive.tar, which is embedded into Drupal, NetSMTP, Console.get-opt, and everything is developed and deployed on Peer. And it's a project, part of the main PHP project. So it's like it's below the umbrella of the PHP core, and it's slightly different from Composer. Because developers, they have to request accounts, say, okay, my name is my real name, this is my email address, and this is the reason why I want to create a new package on Peer. And administrators, they can either allow it and disallow it. And it's not perfect for us because we would have to kind of fly, and we're not trying to involve in any kind of social engineering. We're just trying to like stay technical. So maybe for us, it could be nice to find the bugs that would give us access to a developer account, basically. Just we could take over somebody's account. And there are quite a few pre-authenticated features like bug report, search. So there is some room for mistakes. And also historical package manager developed in 1999 means it's using historical best practice. So maybe things are still wrong nowadays. And it also supports historical PHP versions, which is really great because sometimes some, you know, core, not say core bugs, but some vulnerabilities in PHP, we could exploit them up until some version, and now it's getting harder and harder. So maybe there is some also room for mistake here. And so we just put the code in one of the tools, and I don't know if you can read. Okay, I don't have the right pointer, but basically there is the use of unsafe number generator in a function called reset password, which is not a good sign. Because basically, when we reset somebody's password, it will send a secret token to their email address. And if you come back with the right token, you can just reset the password to any value. So this token has to stay secret at any times, except for the users whose account, who owns the account. And the token is generated with MD5, which is a hash function. So it's not really relevant here. And empty rand between 4 and 13, which is generating an integer value between 4 and 13 with inclusive bounds. So it's not a lot of random values. Okay, interesting. It's also based on user, which is something we control. It's the name of the user with visiting the password. It's based on time, which is the timestamp, but in the replies, we get the dates header, so we know which server, which time is on server, and it's something like it's not too hard to estimate anyway. And pass1, which is the new password to set. So basically, everything is known except a value between 4 and 13. So even taking into account, like, say, maybe some seconds of like delay between when we do the request, time for the email to be sent, and when we get the reply, we can just find password, guess the token with the password with less than 50 trails. And all the existing pair accounts names are public. So we can just go over the list and just find developers with like popular packages and just reset this password and just deploy a new version with backdoors. And the bug is really old. I say it's older than me, but I'm not even lying. It's like it's 15 years old. Okay, so it's not older than me, but like it's here since nearly the very beginning of Peer. And okay, it's pretty good. Like the impact is cool because we can just take over anything, but it would be even better to gain code execution because it's always a goal. And we tried to look for, back in the days, PHP deserialization vulnerabilities were really common and really easy to exploit. If you don't know about this, you can click on this link because it's a Bible for such vulnerabilities. And what you need to know is to exploit it, you need to find gadgets, which are called pop chains, but say depend on what's running on server because you need to import them and find the right classes and just combine everything together to make it happen. So sometimes even you find we call like an unsafe deserialization, you may not always exploit it. And that's what happened here. I found pretty cool bug in the profile edition for administrator to reach the unserialize, but I wasn't able to exploit it. So yeah. But though looking around, we're like, okay, maybe there is something else interesting. And indeed, there is a package submission queue. Every time you want to submit a package, so you have an account, you want to deploy in the package, it's added to a work queue, which is run by asynchronous workers that just take the task and just run it. And this queue is here to generate documentation for packages and then later publish it on Peer. So it's really interesting for us because there are like external commands being invoked. There is a lot of file system accesses. So there's like a lot of room for mistakes. And maybe we could even try to find vulnerability in PHP doc itself. So like, it's pretty interesting. And the code on its own, pretty easy. What I just put in bold is that it's taking the file name, we just upload it, and it's instantiating the class archive tar, which is a way to pass tar archives and just later extract it to a temp folder. That archive tar, like we said, the version it's Peer web is running. It's quite old, and there are also publicly known vulnerabilities in it. Because in this version, which is I think something like 5 years old, there is this CVE, which says, okay, there is no public POC, but it says, okay, it allows write operation with a path traversal because of symlinks. And in the PHP world, being able to write a script outside of the main directory, it's enough to gain code execution 99% of the time because you can just write a new script under the web root. And 99% of the time, there is no permission check or no hardening preventing you to do it. So we just looked at the patch, and I will just show you the patch and give you some glimpse of how the tar format works. It's basically 512 bytes of header with some metadata information, like the name, destination of the links, type of file. Then you have the file itself with some rounding, and then you just repeat for every single file, so there's no compression involved. And then you have 2 entries of null bytes. And there are several specifications here, but the most common one is ustar. I think it's the one you have for Unix star, and it allows you for longer file names, new file types, and so on. And in the patch, I went over quickly, so I just show you the code here. We see there is something related to the type flag being set to 2 for this entry. And if we look at the code of tar, 2 equals same type, which is for symbolic links. So it's still the same as what we saw in the description. So we're on the good way. And there is a third check that was introduced that is trying to check if the destination of the link that was created is still below the destination path of where we are trying to extract the file, which is the PHP directory. So basically, the bug should allow us, by creating a symbolic link, to write anywhere else on the system. So we just created a peer package with a symbolic link, and that's how it works. Yeah, so no lies a pointer. This is the initial state, and in the var.tmp uploads, we have this package we just uploaded, and for now, nothing happened because we are not extracting it. But when the extraction opens, we first create a file called symlink, pointing to somewhere else, the web root, creating a file named evil.php. And this file doesn't exist yet. We just created a link, a reference to this file, but it's not yet. Then we extract a file also named symlink, that will be written into the first file named symlink that will be redirected to the evil.php file. And here we put some, let's say, shell. So it's just a way for us to be able to execute commands later on. And then we just extract the package.xml file just to go through all the other checks before. And we can just change both bugs. So we can basically take over an administrator account or developer account, create a new package, approve it, and exploit the path traversal bug to gain code execution. And now we can just compromise all the peer packages, try to rootkit the server, gain persistent access, and there's not much room for lateral pivot, because even if it's, under the PHP core project, on the server, there is only the peer website. So yeah, why not? But we could maybe compromise installers, or, could be really interesting for threat actors. And I will show you what it looks like. So same setup. Attacker's shell is on the top right. Below we just have the IP addresses and stuff. And I will just manually run the queue, so nothing interesting. And on the left, we'll try to log in with admin and foobar, and it's not working because it's not admin's password. But hopefully we have the exploit. And we'll reset admin's password to foobar. And just taking a few tries, like, I don't know, maybe 20. And now we can just log in as admin and foobar. Awesome. So now let's go upload the package. So we generate first the archive with symlink as a link, symlink as a file, and then package.xml. We go to the release process, edit, load it, and below we see it was executed by the queue. And now if we go to evil.php, we have a shell. So basically code execution on peer. Yeah. The timeline is slightly different because the project is kind of sunsetting. We were, the initial contact was in July 2021. They published fixes on GitHub pretty quickly, like a few days after. And it took 8 months to deploy it on the real production server because there were only a few maintainers that still got access to the server. So it took a little bit of time. But still, thank you, Ken Guest, Mark, and Chuck for the help. If you want to support peer and PHP overall, there is now something called the PHP Foundation, which is several organizations that just group together to make sure the PHP language could just continue to pay full-time developers to work on PHP. And you should still consider moving to Composer because the same packages are also present in Composer. So there is more active community support. So I think we should start to all move there. And the patch is a little funny because basically instead of the empty run function, we just generate 16 bytes of strong entropy randomness, let's say. But if you didn't see it, there is a typo here. So we're just assigning this random value to random bytes, and then we make the MD5 ren bytes. So it's basically every time we reset somebody's password, we just set it to the MD5 of an empty string. So we just told them and they fixed it, but it's pretty nice because that would have been exploitable as well. And now mitigations. You saw it was pretty easy, and I guess that similar vulnerabilities will happen again. Max found at least 3, Reotac found at least 2, and we found 2, and it's pretty crazy. So we have to say that it will happen again for every single package manager and every single ecosystem. And otherwise, on the offensive side, it's always easier. You have to find one bug, one single unsafe random generation to break in. And on the defensive side, they have to kind of try to prevent yet unknown bugs to make sure they won't get owned. So it's always easier on the offensive side. So we need to try to start thinking about reducing the impact of such bugs. Like if somebody gets SE on Composer, we have to find ways to not compromise the entire planet. So I did a little tier list of what could be nice to implement. Basically, 2FA is useless. Vendoring, which is putting all your dependencies in your own source tree and just reviewing all the changes and updating it manually, just useless. You just spend your time reading somebody else's code for no reason. SBOM is pretty fancy, new buzzword now, because it's mandatory, like the White House is forcing companies to do it. It's called software bill of materials, and basically you have to list every single dependency and transitive dependency of your software. But it won't prevent compromise, but at least if you get compromised and like somebody says, okay, there is log4j happening, do you use log4j? You will be able to quickly grep through it and see if you're actually using log4j or if any of the transitive dependency is bundling log4j. So why not? But it's not proactive. It's not preventing it. You can just react faster. Version pinning is basically the same as vendoring. You just fix your dependencies to always versions you know are safe, but every time you need to update your more recent version, you have to go through the changes, and it's like, we will spend so many time on it. There's also optional code signing. Why not? But if it's optional, nobody will do it, so it's not that good. And money, third-party audits, security patches, I think it's great. Like we found this stuff quite easily, and I think if somebody gave money to the PHP Foundation for like auditing PA, so I would have found it, but like in 15 years, nobody ever did it. And security patches, it's like it's playing the long game. I don't know, like if we all start contributing like security, if we all start making security contributions to this project, sandboxing things, just making it overall safer, would prevent like past reversals. That kind of thing shouldn't happen. Like in production servers, you should be CH rooted, and like all this kind of unsafe stuff should be done in a safe way. So I think the best way to go would be the mandatory code signing. And the idea behind it is just for every single time a developer is deploying a package, you would sign it like with a key they know. It's like it's not package signed by the package manager, it's signed by the developer, and you would publish a signature to a public append-only ledger, which is like, let's say, public database, fancy word for public database. And it would be similar to the TLS certificate transparency. So every time you generate an HTTPS certificate, TLS certificate, the provider signing the certificate has to say, okay, I just signed a certificate for this host name. So basically we'll do the same for packages. So every time you download a package, you can just query some third party and say, okay, this is the signature of what I just downloaded. Is it safe or was it compromised by somebody? And also requires some protection against downgrade attacks. Otherwise attackers could be trying to force you to use an unsafe version of the software. But okay, it's just an implementation detail. And Peer and Pyrus try to work in this area, but it was using PGP. And I mean, nobody's still using PGP for mail, so PGP for packages, it's not like, UX and security. It's always hard to make it work together. So there's some initial groundwork done by Paragon Initiatives for Composer. There was a 5 years old discussion, but PHP never really got like proper cryptography functions. They got it only recently. So it's kind of never got traction, and it would require a lot of effort to make it happen. But they still try to put the concept of code signing and try to provide some, test implementations, and it's pretty good. Like, I think, they have some merit. And there is a new exciting initiative called Sixstar, which is basically what I say. It's some RESTful ledger with a public instance where everybody can just say, hello, I am this developer. I have a proof because I'm logged in my Google account or my GitHub account. I can prove I'm this user, and I just release a new version. Can you sign it? And the server will sign it and just store the signature. And now every time somebody tries to install the software, they can just ping them and say, okay, I just got a signature. Is it the right one? And they have a few projects to do it. And it's Linux Foundation project. So I think it's pretty serious. The website looks really nice. It's also a sign of, trust. And there is some initial community adoption with a PR in progress for RubyGem, and all the LLVM tables are already tracked with it. So you can check every time you download LLVM, you can check on this blockchain if you just got the right one. So there is always a mandatory XKCD, and I think you all know this one, which is basically we all rely on some little piece of software wrote by some random person living in some countryside city since 2003. And it will stay true. Like, we always have this dependency to other pieces of software we don't control. Basically, we're just pulling a lot of code from a lot of random places, and we cannot just have some creative control over everything. It's also a bit scary because we could compromise a good chunk of the internet. The attacker level is, look at me. No, I'm just nobody. Time, it's just not even something to track, just less than a week. And money is just not relevant, just in a laptop, and not even a laptop. Maybe on your phone you could do it. So it's pretty scary to be able to just compromise maybe around 20% of the internet that way. And so Sigstore looks really promising. Basically, you would just remove the trust from the middleman. You will never trust the package manager. You will only trust the developer itself, which is already a lot. And I think it's something to kind of lobby for and try to implement in every single package manager, and most especially the new ones. And and as always, open source software security, it's hard because they already like developers. They have only a few security contributions, and you cannot expect maintainers to also, think out of the box and try to add on the software production instance, say, maintain for free, tirelessly. And so basically funding, money. And maybe we could also try to internalize supply chain best practices in DevSecOps team. So like review the way we pull dependencies and we plug everything together, and also obviously audit package managers. Either give money to pentest companies or just to maintainers, so they can just hire some to really have some third-party audit of everything we use basically. So we already released something on our blog where we publish our research. So the Composer article is already public. And next week on Tuesday, we'll release the details of P. So if you want more technical details and more explanations, everything is on the blog. And if you love what you saw, you can come help us. We have hiring position available for volunteer research. We do pretty cool stuff. You will see Simon's talk later. We own Zimbra, WordPress, Rocket Chat, maybe Zabbix, just everything. We just own it. It's pretty cool. So thank you for your time. Feel free to reach out. This is for questions, hiring, anything, Twitter, email, and thank you.